Okay, this is a review for integrated 3. This review will cover graphing quadratic functions, solving quadratic equations, as well as the surface areas of solids and transformations, which we've been talking about for the past couple of weeks. Okay, so let's get started. Number 1 says, given f of x equals x squared and g of x equals the quantity x minus 4 squared plus 6, choose true or false for each statement. Okay, so what I'm going to do first in this problem right here is I'm going to take g of x and I'm going to figure out what the transformations are that they did to that function, which means that I'm going to find b, h, a, and k for that function. Okay, now this one's pretty simple because there is no b and there is no a. Actually they are there, but there's simply one, so we really don't have to worry about those. Okay, h is the one inside of the parentheses with the x, so remember it's always x minus h, so that means that in this case h is 4, not negative 4, 4. K is that number, the constant at the end, okay, outside of the parentheses, so it's h plus k, x minus h squared plus k, which means that in this case k is 6. Okay, now that I found those, I can look at the questions here and decide which one is true, which one is false. So A, g of x is f of x translated up 6 units. Up 6 units means that k must be equal to 6. That's what up 6 units means, and in this case that is true. K is 6. B, g of x is f of x translated left 4 units. Left 4 units means that h must be equal to negative 4. And in this case, that is not true. H is equal to positive 4, not negative 4, so that one's false. C, g of x is f of x translated down 6 units. Well, that's impossible. We already said that it's up 6 units, not down 6 units. So A and C cannot both be true. This one has to be false. Okay, that would mean that k is equal to negative 6, and it's not true. K is equal to positive 6. And D, g of x is f of x translated right 4 units. Again, that's the opposite of B. We said false for B. This one, right 4 units, means that h equals positive 4. Okay, and that one is actually true. There you go. Okay, now let's look at number 2. It says, what are the zeros of the function? Remember, zeros is equivalent to the x-intercepts, or we can also call them the solutions, or we can also call them the roots of the function. They all basically refer to the same thing. Okay, the zeros, we're going to find them by setting the equation equal to 0. So what I'm going to do is replace this y with 0. And now since it's already in factored form or in intercept form, it makes it real easy to solve. Okay, what I'm going to do is set up each factor equal to 0. So I'm going to set this one equal to 0, this one equal to 0, and this one equal to 0. Okay, that first one makes no sense. I can say negative 2, let me put that in black. I could put negative 2 is equal to 0, and it makes no sense, so I'm not going to get a solution out of that. But the next one will give me a solution. 4x minus 2 is equal to 0. To solve that one, I'm going to add 2 to both sides. That cancels. 4x is equal to 2. And then I'm going to divide by 4 to isolate the x. X is equal to, simplify that fraction, you get 1/2. That's the first one. The other one I need to solve also. 5x plus 3 is equal to 0. I'm going to subtract 3 from both sides. So I get 5x is equal to negative 3. And then I'm going to divide by 5. And so x is equal to negative 3 over 5. Those are the two zeros, or x-intercepts, or solutions, or roots. They all are equivalent to each other. Okay, number 3 says graph y equals x squared minus 4x plus 1. Okay, since they gave this to me in standard form, not in factored form, what I'm gonna have to do is find the vertex first. Okay, so I'm gonna find the vertex by using the vertex formula for the axis of symmetry, which is negative b over 2a. use that to find the axis of symmetry and at the same time the vertex. Okay, so in this case, A is 1, B is -4, right? You can see that in the function. A is right here, B is right there, -4. Use those two numbers to find the axis of symmetry. X equals -b, -4, over 2 times 1. -4 becomes 4. So 4 over 2, which is 2. X equals 2. That is actually the axis of symmetry already. Okay, this formula is for the axis of symmetry. We just found that x equals 2. Okay, remember the axis of symmetry is a vertical line that contains the vertex of your parabola. Okay, now question B is, what is the vertex of the parabola? What I'm going to do is I'm going to take this x equals 2 and plug it into the original function to see what I get for y. Okay, so here we go. Y equals x squared minus 4x plus 1. Plug in 2, which means that here I have to plug in also 4x plus 1. Plug in 2 right here and right here. So we get y equals 4 minus 8 plus 1, which is going to give me -4 plus 1, which gives me -3. So my vertex is 2, which is the x value that I found before, right here, and the y value is -3. That's your vertex. Okay, so what's the vertex of the parabola? 2, -3. I'm going to go ahead and find it on the graph right there. Write the axis of symmetry and label it on the graph. There's x equals 2. It's a vertical line. I'm going to draw it right here. Vertical line. Find the maximum or minimum value of the parabola. Okay, so we haven't finished graphing it actually. Okay, so the vertex is 2, -3 right here. I need to find more points to be able to label where the parabola passes through. Okay, so what I'm going to do is I'm going to make an XY table. We have to do this if it's not in vertex form or in factored form. Okay, I'm going to put my point that I already found there, 2, -3, and I'm going to find a couple of points before that and a couple of points after that. Okay, so before 2 is 0 and 1, after 2 is 3 and 4. So what I'm going to do is I'm going to plug in those numbers into my original function so that I can see what I get as my rest of my points, and then I can graph the parabola. Okay, so I'm going to erase a lot of this work right here so that I can do the rest of the work. Okay, here, let's erase this. So I'm going to plug in 0. So that means I'm going to go y equals x squared minus 4x plus 1, plug in 0 there, and I'm going to get 0, 0, 1, which is what I get, y equals 1. Plug in 1, y equals x squared minus 4x plus 1. 1 squared minus 4 is 1 minus 4 plus 1. 1 minus 4 is -3. -3 plus 1 is -2. Okay, plug in 3. Now, since this is a parabola and this term in the middle, this is the vertex, I should repeat the same numbers again, but just to double check, I'm going to go ahead and plug in 3. I'm pretty sure I did it correct, and so I should get -2 because the numbers do repeat in a parabola, right? So that's 9 minus 12 plus 1. 9 minus 12 is -3. -3 plus 1 is -2, just as I suspected it. And the next number should be 1, right? Because they're going to repeat. Remember the parabola, the numbers are going to repeat. This is the vertex, and so these numbers are going to repeat, and then these numbers are going to repeat. So I should get 1, but just to double check again, let's do it. Y equals x squared minus 4x plus 1. Plug in 4 in this case. I'm going to get 16 minus 16 plus 1. 16 minus 16 cancels, leaving me with 1. There you go. So just as we suspected, they do repeat. So I'm going to go ahead and graph those points. 0, 1 is right here. 1, negative 2 is right here. I need to really mark these points so you can see them clearly. 2, negative 3 is already there. That's the vertex. 3, negative 2 is right here. And 4, 1 is right here. And so I connect those points to make my parabola. There you go. Now we can answer all the questions. Find the maximum or minimum value of the parabola. That's the last question, actually. So maximum, you notice that this parabola does not have a maximum, right? Remember, maximum only exists if the parabola has a limit, an upper limit, which it never crosses. This parabola does not, okay? It's going to keep going up forever, so it does not have one. None. Minimum, it does have a minimum, right? The lowest point of this parabola is negative 3. So the minimum is negative 3. And there you go. So just to recap, how do we graph this parabola? You start with the vertex, x equals negative b over 2a. That's your formula to find the axis of symmetry and the vertex. Using that, we found x equals 2. Right here. Then we took that 2 and we plugged it into the parabola right there to find negative 3. That's the vertex of the parabola. We used that as the vertex in our table, and we picked 2 points before and 2 points after. You actually only need one, really, but just to make it a little bit nicer and clearer, easier to see, we went with 2 points on each side. We plugged those into our original parabola and our original function, and we got 1, negative 2, and 1. We plot those points and we got it. The axis of symmetry is a vertical line, and since it's a line, it must always be written in this form, x equals 2. It is not correct to just write 2. That is not the axis of symmetry. The axis of symmetry is x equals 2. And then what's the maximum and the minimum? The maximum, it doesn't have one because it keeps going forever. The minimum is the lowest point of the graph, which is negative 3. Okay, let's keep going. Number 4, solve. Negative 5 times the quantity 2x minus 3 squared equals negative 45. Okay, we're trying to solve this quadratic equation. This is actually one of the easiest ones to solve. Okay, here's what I'm going to warn you against. Do not do this. Watch as I do what you're not supposed to do. 2x minus 3 squared means 2x minus 3 times 2x minus 3 equals negative 45. Negative 45. And then you're going to try to do this. You're going to multiply 2x times 2x. You're going to FOIL, and you're going to get 4x squared minus 6x plus 9 equals negative 45. And then you're going to distribute the negative 5, and then you're going to combine like terms, and then you're going to make a mess. We're not doing this in this case, okay? It is much, much easier to solve than that. If you see a problem like this where it's a quantity squared and the x is in there, it is much easier to solve. What you're going to do instead is you're going to divide everything by the number in front, which is negative 5. Because that negative 5 and that negative 5 is going to cancel. So you're going to be left with 2x minus 3 squared equals negative 45 over negative 45, which is 9. I mean negative 45 over negative 5, which is 9. And then it's very easy to solve from here. I want to get rid of this square, so I'm going to take the square root of both sides. That cancels, leaving me with 2x minus 3 is equal to, here's where the mistake usually happens, not 9, 3, but not just 3, plus or minus 3, right? Radical 9, or the square root of 9, is not just 3, it's positive or negative 3. There are two solutions here. Okay, and finally we're going to solve it. I'm going to split it up into 2. 2x plus 3 is equal to 3, and 2x plus 3 is equal to negative 3. Solving the one on the left, I'm going to subtract 3 from both sides. 2x is equal to 0, which means that x is equal to 0. And the one on the right side, subtract 3 from both sides. 2x is equal to negative 6, which means that I divide by 2 and I get x equals negative 3. And those are your two solutions, 0 and negative 3. Okay, number 5, factor 30y to the third power minus 6y squared plus 12. Okay, what it means by factor is take out the GCF and then see if you can factor any further. In this case, it looks like the only thing I'm going to be able to do is to factor out the GCF. Okay, so 30y cubed minus 6y squared plus 12, what do they all have in common? Looks like I can divide them all by 6. And that's it, right? You cannot divide by y, you cannot divide by y squared, you cannot divide by y cubed, you can't do anything other than divide it by 6, okay? So if I divide this by 6, I'm going to get 5y cubed minus y squared plus 2. And that's it. There's nothing else we can do. It's not a trick question. It's just trying to see if you guys know how to factor out the GCF. Okay, now let's look at number 6. It says factor x squared plus 29x plus 210. Make sure you guys understand the difference between factor and solve. If it says solve, we must end up with something that looks like this. X equals something, 4, or x equals 10, whatever, right? If it says factor, it just wants us to end up with something in parentheses and something outside, or maybe parentheses times parentheses. It wants us to break up the polynomial into its factors, okay? You don't actually have to go ahead and solve for something. So don't confuse the two things. This one is just saying to factor, so we're not going to end up with a solution. There is no solution because it's not an equation, okay? So let's get started. What I'm going to try to do is to find the factors of 1 and 210. So in this case, a equals 1, b is 29, and c equals 210. Let's fix that. 210. Okay? So some of you guys learned it this way. You multiply a times c. A times c, which is 210. So you put 210 here, and you figure out the factors of 210, what numbers multiply to make 210, but also add up to make 29, okay? So we went ahead and did this before. We find all the factors of 210 until we find a pair that makes 29. So for example, I see 1 times 210, which makes no sense, but I'm going to go ahead and write it. 1 times 210, 2 times 105, and so on, right? 3 times 70, and so on until I find the one that when I multiply them, when I add them, it makes 29. Okay. Now let's think here. 10 times 21 is 210, but it doesn't make 29. Oh yeah, I think I see it. It's 14 times 15. You can test that on your calculator. 14 times 15 gives me 210, and when I combine them together, it makes 29. Those are my two factors. Some of you guys learned how to do this with x factor. I'll show you real quick what I just did. Okay. What I just did is I put the 29 there and the 210 there, and I did the exact same thing that we've been doing. We figure out what two numbers multiply to make 210, and they add up to make 29, and they are 14 and 15. Same thing. Okay. Now, what do you do with those two factors, the 14 and the 15, is you're going to factor by grouping, like this. You're going to write out all the terms of your function, of your equation, of your expression. X squared plus, you're going to take the two factors that you just found, 14, x, and 15, and don't forget to put an x next to them, because you're basically breaking up the 29x into its two pieces, 14x and 15x, plus 210. And then you're going to factor by grouping, right? Group these two together, group these two together, and factor each one. On the first one, I see that they have an x in common, so it's x plus 14. On the second one, they have a 15 in common, so it's x plus 14 as well. And then I see that they both have x plus 14 in common, so I'm going to write that, x plus 14, because both of these things have an x plus 14 in them. And the final remaining factor is going to be x plus 15, which is this one and this one. When I take x plus 14 out of each one, x plus 15 is what's left. And that's it. That's your final answer. Do not go ahead and go further because there's nothing to do. Some of you guys are going to do this. And that would be incorrect. This is not an equation that you need to solve. It's just an expression that you need to factor. So right there where I highlighted, circled in yellow, that's your final answer. Okay, number 7, much simpler problem. Everybody should be able to handle this one. It says, does each of the following result in 4x squared minus 25? So really what you have to do is check each one of the 4 to see if your result after you multiply them or simplify the expressions, it's 4x squared minus 25. So part A, 2x times 2x, I'm going to FOIL this one, gives me 4x squared. 2x times 5 gives me 10x. Negative 5 times 2x gives me negative 10x. And negative 5 times positive 5 gives me negative 25. The positive 10x and the negative 10x are going to cancel, leaving me with 4x squared minus 25. That's what I'm looking for, so the answer is yes for that one. Okay, part B. Let's do this one in blue so you guys can tell it apart. 4x times x, 4x squared. 4x times negative 1, negative 4x. 25 times x, positive 25x. And 25 times negative 1 is negative 25. The negative 4x and the positive 25x here are not going to cancel, but they're going to combine to make positive 21x. So it's 4x squared plus 21x minus 25. And there's nothing else I can do or cancel to simplify. So that one is not going to give me what I want. So the answer for that one is no. Okay, let's do the next one in red so we can tell it apart. It's 2x plus 5 squared, which means I multiply it times itself, minus 20x minus 50. So let's simplify this. I'm going to FOIL here on the front. 2x times 2x is the first one, 4x squared. 2x times 5 is 10x. 5 times 2x is another 10x. And 5 times 5 is 25. And then there's a minus 20x over here and a minus 50. I simplify as much as I can. I have a 10x, another 10x, and a negative 20x. 10x plus 10x is 20x. Subtract 20x, they cancel. They all go away. The positive 25 and the negative 50 make negative 25. And then there's a 4x squared in the front that does not combine with anything else. So it's 4x squared minus 25. That's what I want. So the answer for that one is yes. Okay. And the last one, I'm going to make some space for it by erasing this blue one here. Now I'll make it in yellow so you guys can tell it apart. 2x plus 5 squared, so it's minus 5 times 2x minus 5 plus 20x plus 50. I believe this one's not going to work, but let's finish to check it out. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Right, that's that one. Negative 5 times 2x is negative 10x again. And negative 5 times negative 5 is positive 25. And then to that, add a 20x and a 20x, and a 50. Let's simplify. Negative 10x and negative 10x and positive 20x all cancel each other out, right? That's negative 20x plus 20x. The positive 25 and the positive 50 make positive 75. So what I have at the end is 4x squared plus 75. That's not what I want, so the answer to that one is no. All right, let's move on to this one right here, number 10. What is the solution to 2x squared minus 20x is equal to negative 8x? Okay, so this is a quadratic equation that we need to solve. See how it's asking for the solution. So that means that at the end, we should end up with x equals something. That's the difference between solving and factoring. We don't have to factor this. We have to solve it all the way through. Okay, so you have a lot of options to solve these quadratic equations. You learned a bunch of different ways. You can use factoring, possibly. You can try to complete the square, or you can try to use the quadratic formula. Okay, either one that you use should work out. Okay, actually no, factoring doesn't always work, but the other two always work. So let's start with factoring. Let's try to factor because it's usually the easiest method that people like. Okay, so if we're going to start by factoring, what I need to do first is move that negative 8x over to the left side. So let me write it over here so I have a little more space to work. 2x squared minus 24x is equal to negative 8x. I'm going to add 8x so that I could set it in. Oops, I just copied it wrong. Let me erase all of this stuff. Let's do it again. 2x squared minus 24 equals negative 8x. It was not 24x like I copied it before. We're going to add 8x. So we can make it equal to 0, and we want it in standard form. So that's going to be 0 right there. On the left side, I'm going to have 2x squared plus 8x minus 24. Now the first thing I notice is that everything is even here. So I can make this equation much simpler if I simply divide everything by 2. And I can do that because 0 divided by 2 is still going to give me 0, right? That doesn't change. But on the left side, I get much simpler numbers. I got x squared, 4x, and negative 12. And now we can try to factor, okay? In this case, a is 1, b is 4, c is negative 12. So to try to factor, I'm going to multiply a times c, which is negative 12. And I'm going to try to find the factors of negative 12. What makes negative 12? 1 and 12, but there's no way that that's going to give me a 4. 2 and 6, that might work because I want a negative 12 and I want a positive 4. If I make this one positive and this one negative, that should work. Negative 2 times positive 6 gives me negative 12, and negative 2 plus 6 gives me 4. Those are the two that I want. So what I write is my function like this, my equation, x squared minus 2x plus 6x minus 12 equals 0. This is called factoring by grouping. Okay, what you're really doing here is you took the 4x and you split it up into two pieces, negative 2x and positive 6x. Together, these two combine to make positive 4x. So you didn't really change the equation. It's still the same equation. Okay, but now we're going to factor by grouping them. We're going to group these two together, and we're going to group these two together. Factor each one. The first one, x factors out, leaving you with x minus 2. And the other one, 6 factors out, leaving you with x minus 2. I notice that both of them have x minus 2 in them, so I factor x minus 2. And inside of the other parentheses, I'm going to have x plus 6, which are these two right here. That equals 0, and then I set each one equal to 0. X minus 2 equals 0. X plus 6 equals 0, and solve. This one gives me x equals 2, and this one gives me x equals negative 6. And those are my solutions. Okay, number 11 and 12 are about the same information. A sphere has a diameter of 10 meters. the diameter is multiplied by 3. What happens to the surface area and what happens to the volume? Okay, so we talked about this recently. The diameter is being multiplied by 3. The dimensions are being multiplied by 3. Here's how the rules usually work for solids, okay? It's basically determined by how you change the dimension. Let's say you change the dimension by a number n, in this case 3, but it could be 4, it could be 6, it could be whatever. What happens to the surface area? The surface area does not change, does not get multiplied by n. It gets multiplied by n squared. And the volume gets multiplied by n cube. So let me just give you for example. Let's say I have a sphere with a diameter of 10. Let's say I multiply the diameter by 2. Then what happens to the surface area? It gets multiplied by 2 squared, which really means it gets multiplied by 4. What happens to the volume? It gets multiplied by 2 to the third power, which is 8. It's always going to work out that way. If you change the dimensions of the solid by any number, then the surface area is going to change by that number squared. The volume is going to change by that number cubed. Okay, so for 3, if I change the dimension by a factor of 3 or multiply by 3, then the surface area is going to change by 3 squared, which is 9. So what's the effect on the surface area? Gets multiplied by 9. That's what the answer is. If the diameter is multiplied by 3, the area it's multiplied by 9. The volume will change by 3 cubed, which is 27. So what happens to the volume? I'm going to write it right here. The volume gets multiplied by 27, and so on. I could keep this going. I could say, okay, what if I change the dimension by 4? Well, then the surface area will be 4 squared, or 16. It gets multiplied by 16. The volume gets multiplied by 4 to the third power, which is 64, and so on. 5. What happens to the area? It gets multiplied by 25. What happens to the volume? It gets multiplied by 125. And so on. You could make these generalizations for any kind of solid. As long as you change all of the dimensions by the same factor, then you can change the surface area by that number squared, and you can change the volume by that number cubed. Okay, number 13 is about this pyramid. It says find the surface area of the pyramid, show the formula used, and your calculations. Okay, surface area of a pyramid. Here's the formula you need to use. Okay, 1/2, and you should have these memorized. We've been looking at these for 5-6 weeks already, maybe more. 1/2 PL plus B, where P represents the perimeter of the base, L represents the slant height of the pyramid, and capital B represents the base area, right? The area of the base. So using those three, which I'm going to figure out right now, I can just plug them into the formula and solve. Let's start with the perimeter. Let's do it all up here. The perimeter of the base. Well, the base is a square. How do I know it's a square? Because they tell me right here. It's a square pyramid. So the base is a square, and each side is 6. So if each side is 6, the perimeter is going to be 6 plus 6 plus 6 plus 6, or simply 6 times 4, which is 24. So the perimeter is 24 inches. The slant height. The slant height is the height that is slanted, that is not vertical, right? They gave me that one. It's 10.35 inches. If they do not give you the slant height, then you have to find it, okay? So for example, let me just do a for example right here. Let's say that instead of the slant height, they gave me the vertical height right here. h. Then I could use that value in this side, which is 3, because it's half of 6, use the Pythagorean theorem, and then I could find the slant height. Okay, but in this case they gave it to me, so I'm going to go ahead and use it. And finally I need to find b, right? Base area, or area of the base. The area of the base is, since the base is a square, it's going to be 6 times 6, right? Length times width, or base times height, or side times side. 6 times 6, which is going to be 36 inches squared. All right, plug all of that in into the formula and you'll be done. S equals 1/2 P L plus B. Plug in all the values. P is 24 inches. L is 10.35 inches. Inches times inches becomes inches squared. And B is 36 inches squared. Multiply all of that out. This is the time to take out your calculator and do that multiplication. My calculator says that this first number is 124.2. Add 36 to that. And so our final answer is 160.2 inches squared. There you go. Part B. If all the dimensions of the pyramid are cut in half, how will the surface area and volume change? Okay, so that goes back to the last problem. If the dimension change is a factor of 1/2, what happens to the surface area? What happens to the volume? Same rule still applies. If n is 1/2, then the surface area is going to be n squared, which is 1/2 squared, which is 1/4. So the surface area will be 1/4 of the original surface area. Okay, if you cut every dimension by 1/2, then you don't cut the surface area by 1/2, you cut the surface area by 1/4. How will the volume change? Well, again, the same rule still applies. It'll be n cubed, which in this case is 1/2 cubed. 1/2 times 1/2 times 1/2, which gives you 1/8, 1/8. The volume will change by 1/8. It'll be 1/8 of the original. Okay, let's move on to number 15. A candle in the shape of a square pyramid is to be made from 150 centimeters cubed. Ooh, this is not surface area. Centimeters cubed, that's volume. Okay, so right away I know I'm going to have to find the volume of this square pyramid. Now you do have these formulas on your notes, although we didn't use them as much as the surface areas formula. So I'm going to have to remind you of this one. The volume of a square pyramid is going to be 1/3 area of the base times height of the pyramid. Right? Area of the base times height of the pyramid. We're going to use that. Now since the base is a square, that means that the area of the base is going to be side times side, right? Whatever the side is. So let's continue reading. If the candle's height is twice the side length of the base, okay, stop right there and interpret what that means. The candle's height is twice the side length of the base. I'm going to write that down in algebraic terms so that I understand what it's trying to say. The candle's height is twice the side length of the base. So H is equal to 2S, where S is the side length of the base. So if H is equal to 2S, what could the side length of the base and height be to the nearest tenth? Okay, so this is going to take me a little bit of work to figure out. So I know that the area of the base, since it's a square, is side times side. I know that the height of the pyramid is 2S because they tell me that the height is twice the side length. So using those two things, I'm going to plug them into the formula. And knowing that it's 150, the total volume is 150. Right? V equals 150. So using that 150 for V, using S times S for B, for area of the base, and using 2S for H, I can solve this. Okay, so let's do this. 150 is equal to 1/3 S times 2S is going to be 2S cubed. So let's simplify that down a little more. I'm going to continue working down here, and I'll erase it after when I'm working on number 16. 150 is equal to 1/3 times 2 is 2/3 S cubed. And then I'm going to solve this. Okay, first thing I'm going to do is get rid of the 2/3 by multiplying by the reciprocal, which is 3/2. Multiply by 3/2. Because the 2 and the 2 will cancel, the 3 and the 3 will cancel, leaving me with S cubed on this side. On the left side, it's 3/2 times 150 is going to be 225. Because 3 times 150 is 450, divided by 2 is 225. And finally, if I want to solve this for S, I need to get rid of this cube, which means that I'm going to take not the square root, but the cube root. What number do I multiply by itself 3 times to get 225? And the answer to that is going to be approximately 6.08, according to my calculator. Okay, in order to find that number, you need to put 225 into your calculator and then look for the cube root symbol, which looks like this. Right, you need to put 225 in there. That's how your calculator is going to handle it. So approximately 6.08 to the nearest tenth, it says, so approximately 6.1 centimeters. Okay, now let's look at number 16. It says a college campus covers an area shaped like a rectangle that is 5 miles long and 2 miles wide. If there are usually 30,000 people on campus, what is the average population density on the college campus? Okay, so density is something that we actually haven't talked about much, okay, except for a couple of word problems here and there. So let me just really quickly explain to you guys what we mean by density. Density is usually defined, the easiest way to understand it is to say density is equal to the amount of stuff, and that stuff could be whatever you want it to be. In this case is the amount of people, right? Amount of stuff divided by the amount of space. How much space? How much stuff is there in how much space? So usually when we talk about density, we're talking about solids, and so we mean amount of stuff, meaning the mass of the stuff. So we're saying, what's the density of gold? Then we weigh the gold, we check its mass, and we divide it by its volume, how much space it takes, mass over volume. In this case, it's not a solid. We're talking about people on a college campus, so it's not mass over volume. But we can see how much stuff there is. They told us there is 30,000 people. So it's the number of people over the amount of space. How much space are these people taking on this campus? Okay, so they gave us the idea that the campus is rectangular and it's 5 miles long by 2 miles wide. How much space is there on this campus? That means what's the area, right? What's the area of this campus? 5 times 2, length times width, is 10. 10 square miles of space. Miles, not meters. So 30,000 people in 10 square miles of space. I'm just going to go ahead and divide that real quick. That's really easy to divide. Just cancel the last zeros. So my solution is 3,000. 3,000 people or persons per square mile. That is the population density of this college campus. Every square mile has 3,000 people in it, okay? On average, that's the average population density. So the main thing you got to remember in this problem, or anytime you see density, is this, okay, what I just said. the amount of stuff divided by the amount of space. And stuff could be anything that we're talking about. In this case, it was people, but it could be the mass of a solid, or the mass of a, or how much solution is in a liquid, for example. Okay, that density is amount of stuff divided by the amount of space that it occupies. Okay, and a space could be area, like it was in this case, or it could be volume. Right? Volume also signifies three-dimensional space. Area signifies two-dimensional space. But it could be area, it could be volume. Okay, you're just comparing how much stuff there is to how much space it takes. Okay, now let's look at number 17 through 19. It says refer to the square pyramid. Okay, so 17. What's the surface area of the pyramid? Again, another formula that you should have memorized already. If you haven't, make sure you study these. We've been looking at them for a long time now. You should have these. Okay, so a pyramid is going to be surface area 1/2 PL plus B, where P is the perimeter of the base, L is the slant height, and B, capital B, is the area of the base, or base area. Okay, so using those three things, I can figure this out. Let's start with P. P is going to be the perimeter of the base. It's going to be 5 plus 5 plus 5 plus 5, or 5 times 4, 20 inches. L is the slant height. Once again, they gave it to me. It's 8.5. Remember, slant height is slanted. It's not a vertical height. And B, the area of the base, since it's a square, it's 5 times 5, right? Side times side, 25. Use those three numbers, plug them into the surface area formula. So S equals 1/2 P, which is 20, L, which is 8.5, plus B, which is 25. And this is where you take out your calculator. So this is going to be 1/2 times 20, which is 10, times 8.5 is 85. We actually did not need a calculator. You could do that in your head. 1/2 times 20 makes 10. Right? 1/2 times 20 means what's 1/2 of 20? 10 times 8.5 is 85, because you moved the decimal over once. And then we're going to add 25 to that, leaving us with 110 inches squared, square inches. Okay, question number 18. If all dimensions of the pyramid are tripled, how will the surface area change? All dimensions of the pyramid are tripled. How will the surface area change? Once again, we've done this before. All dimensions of the pyramid are tripled. That means n, which represents the dimension change, is 3. What happens to the surface area? And I'm guessing they're all probably going to ask me about the volume after that. So I'm going to put that one there. What happens to the surface area? Well, it's going to get multiplied by n squared, which is going to be 9. So how will the surface area change? It will be multiplied by 9. What's going to happen to the volume? It's going to get multiplied by n cubed, which is 3 times 3 times 3, which is 27. So if they ask me about the volume, it will be multiplied by 27. And I believe that is question number 19. Yes. If all dimensions of the pyramid are tripled, how will the volume change? It will be multiplied by 27. Okay, and that's it for that one. So memorize the surface area formulas and remember this. What happens to dimensions? What happens to the surface area and volume when you change the dimensions by a certain number? Okay, surface area is that number squared. Volume is that number cubed. Okay, number 20. A hemisphere sits on top of a cylinder. Okay, so we're going to find the surface area of the composite figure to the nearest tenth. You know what? I'm going to do two separate things here. Surface area of the cylinder first, up here, and I'm going to do the surface area of the hemisphere down here so I don't confuse them. Hemisphere will be down here. So, surface area of the cylinder, I need the formula. You should have it memorized. The formula for the surface area of a cylinder, CH plus 2B. C is the circumference of the base. H is the height of the cylinder. B is the area of the base, which is a circle. So let's do that real quick. Oh, before we do that, I need to look at the cylinder and adjust my formula, right? If I'm looking at the cylinder right here and I'm looking for the surface area, then this formula is not correct, okay? CH represents the lateral area, basically everything around the sides of this cylinder. 2B represents two bases, the base down here and the base up here. Except that this cylinder does not have two bases. It only has one base because this base right here is not part of the total surface area because it's covered by this hemisphere. So I need to adjust my formula and change it to CH plus B only, not 2B. Okay, now let's do this. Circumference. Circumference is 2 pi r. That's a formula that you should have memorized, which is 2 times pi times r. R is not 12, r is 6, right? 12 is the diameter, so 6 is the radius. So the circumference is 12 pi. Because it's 2 times pi times 6, 12 pi. Okay, the height, well, that's easy. It's already given to me. That is going to be 10. I'm going to put it there. And the B, the area of the base. The area of the base here is pi r squared, right? A circle is pi r squared, which in this case is pi times 6 times 6, so 36. So 36 pi. There you go. So I have my numbers. The surface area then of the cylinder is C, which is 12 pi, times H, which is 10, plus B, which is 36 pi. So that leaves me with 120 pi plus 36 pi, which I can simplify down to 156 pi. I'm going to leave it like that in terms of pi. If later I have to change it to decimal, then I'll change it to decimal. Okay, so right now it's 156 pi because it's 120 pi plus 36 pi. Alright, the surface area of the hemisphere. Another formula that you should have memorized is the surface area of a sphere, 4 pi r squared. But since we're only talking about a hemisphere, half a sphere, the formula changes to half of that, 2 pi r squared. Alright, using that and the fact that I know r is 6, then I can find that this is 2 pi, 6 times 6 is 36, give me a total of 72 pi. Alright. Found the two surface areas. I found the surface area of the cylinder and I found the surface area of the hemisphere. Put those two together and that is the total surface area. So the total surface area is 156 pi plus 72 pi. Put them together and we get 228 pi. Let me just double check that on the calculator. And yeah, it's right, 228 pi. Now it says what is the surface area to the nearest tenth, so that means that I am actually going to multiply times pi, 3.14159. So multiply that times pi, and so the surface area is going to be 228 times 3.141. This is going to be 716.3 feet squared. My total surface area is 716.3 square feet. So once again, let me just recap real quick. You will find the surface area of the cylinder using this formula, but taking out one of the b's, because it only has one base, it does not have two bases. So we use this formula instead, because you can see it only has the bottom base. The top base is not included because it's being covered by the hemisphere. So use that formula. C stands for circumference, which is 2 pi r. H stands for the height of the cylinder, which in this case was 10. B stands for the area of the base, which is going to be pi r squared. In this case, it ended up being 36 pi. Plug them in, and we ended up with 156 pi. Then we found the area of the hemisphere. The area of a sphere is 4 pi r squared, but since we have a hemisphere, which is half a sphere, it's 2 pi r squared. Using r equals 6 again, we got 36 right here. 36 times 2 is 72 pi. The area of the hemisphere is 72 pi. Then we added the 156 pi plus 72 pi, which gave me 228 pi. And then it says rounded to the nearest tenth, so I went ahead and multiplied times 3.14 to get my estimate, which is 716.3 square feet.